Math Day, Great Day, Math Lead learners. Welcome to Mathematics Lead channel, where we turn your math worry into mastery. I am teacher Joanne, and together let us have fun while learning. For today, we're going to discuss how to illustrate tangents and secants of circles. But before that, let me introduce to you our learning objectives. At the end of the lesson, the students should be able to let us read. A. Identify and illustrate tangents and secants of circles. B. Define and understand the difference between secants and tangents of a circle. And lastly, visualize secants and tangents using graphing tools. For our engaging activity, we are going to identify the parts of the circle. For the first one, we have segment SU. What is this? Exactly, that is our diameter. And the second one would be our radius, which is the half of the diameter. The third one is our chord. And lastly, point R is the center. Very good, you're doing great. But let's move on to activating knowledge. We already know that the diameter, radius, center, and also the chord are parts of the circle. But today we're going to discuss the lines that interacts with the circle. It is not part of it, but it crosses or it touches the circle. What does it mean? So we have the secant and the tangent as our lines that intersects with the circle. When we say secant, it is a line that intersects at exactly 2 points of the circle. Take note of that. 2 points of the circle. So in this case, we have the circle P and then the line QR. You can see that the line QR intersects the circle at exactly 2 points. That's why we already know that the line QR is our secant. But what if, teacher, you are given this kind of example? We have the point P and then the line AB. It doesn't touch the circle. It doesn't cross the circle. What is this? Let's see. You already know that line. Extend both ends. You can see, that's why there's an arrowhead. It is extending. If you extend that, what can you observe? Does it touches or crosses the circle? It does cross the circle. That's why it is a secant. At how many points does this line intersects with the circle? 2 points. That's why it's a secant. Let's have another example. We have line CD. Let's see. Let's try to extend it again. When you extend the line CD, what can you observe? It touches the circle at exactly 2 points again. That's why this is a secant. But teacher, look at this example. We have the line DE. It only touches the circle. It intersects at exactly 1 point. What is this? This is our tangent. When this line intersects at exactly one and only point, it is a tangent. The point of intersection of the line and the circle is called the point of tangency. You know, this is the circle, this is the line of tangency. This is the line, and they intersect at this point. This point is called the point of tangency. That's it. So here, on our given, we have the circle V and line AU. What is our point of tangency here? Exactly, it's point U. How about this case? What if you're given another example wherein it doesn't touch the circle, but you already know that line extend both ends. So here, let's extend it. Okay, now we extended it. Oh, it touches the circle at 1 point. This is A. This line is tangent to a circle. We already know that. And this point is our point of tangency. But let's go to the theorems of tangent line. Let's see. We know that if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. When we say perpendicular, again, perpendicular lines meet or intersect at right angles. So look here. This line AB is tangent to circle Q, right? It is tangent to it. But if we're going to draw a line from the point Q, which is the center, to the point of tangency, okay, we connect that, and then here is our, okay, the line that is tangent to the circle. When we connect that, we already know that this will form 90 degrees. That's why they are perpendicular to each other. Makes sense. But on the second theorem, if a line is perpendicular to the radius of a circle at its endpoint that is on the circle, then the line is tangent to the circle. Remember, endpoint that is on the circle. So here's the circle on the circle, and then here, if this line and then this, which is the radius, it is perpendicular, you know that this line is tangent to that circle. Can you follow? Nice. And for the third one, the third theorem, if two segments from the same exterior point are tangent to a circle, then the two segments are congruent, which means that here on our given example, GW and DW are tangent to circle E. And GW and DW have the same exterior point, which is W, the point W. We know that if GW is 2 centimeter, then DW is 2 centimeter. If GW is 8 centimeter, then DW is 8 centimeter. If GW is 60, then DW is 60. But let's have another example. If circle A, we have circle A and BC and CD are tangent to this circle, we know that BC, they do have the same exterior point, which is the point C. Then we know that BC and CD are equal. They are congruent. If BC is 5, CD is what? Exactly, it's 5 units. Now, let's move on to the common tangent. A common tangent is a line that is tangent to two circles in the same plane. So here we're going to use two circles, and then if these two circles are tangent to one line, it's tangent to one line, for example here, then you know that this line is the common tangent. Yeah. For this case, line AC is the common tangent because it is tangent to two circles. But there are two types of common tangents, which are the external tangents and internal tangents. What are the differences? Okay. So when we draw segments from the center of the circle, we connect the center of the circle here, and it does not intersect the tangents, then there are external tangents. But when we draw segments from the center of the circle, you can see it here, it intersects the tangent, right? That's why this is internal tangent. Look here, another case. If we draw another line here, we connect the center of the circle, okay? Then, what can you observe? Does it intersect? That is, intersect the tangents? Yes, right? So what is this? That is an internal tangent. Very good. So, I see that, okay, you already learned the differences of these. Again, when we say secant, it intersects at how many points? 2 points. When we say tangent, it intersects into 1 point. And remember that there are two types of common tangents. But when we say common tangents, there are two circles, and the line is tangent to these two circles. And if these two circles, okay, if you draw a line that connects the circle of these two circles and it intersects the common tangent, then that is an internal tangent. But if it does not intersect with the tangent, then it is an external tangent. Clear? Clear, clear? Give me a thumbs up there. Okay, now let's move to the developing competencies. So, I want you to get a graphing paper and then let's do this activity. For the first one, plot a circle with a center at the origin 0, 0 and radius 2. I'll be giving you 1 minute for that. After that, draw a line that touches the circle in one place. Remember, touches the circle in one place. So this is our tangent. And for the third one, adjust the line further that intersects the line at two places. So we're going to draw another line wherein it touches the circle at two places or 2 points. That would be the second. Okay, very good. After you are done with your activity, you can send that to me through your Google account. I'll be waiting for that, for your answers. Okay, that's all for today. Great job, learners. Thank you for listening. Goodbye.